Hello again. In this second video tutorial, we'll build a web application for a marketplace which is deployed in the form of a smart contract on Bitcoin. Now, the smart contract will keep track of all the listings being posted on the marketplace and also ensuring that the seller will actually get paid the appropriate amount. Again, an important thing here is that there is no backend server or service that you need to rely upon to achieve this. So without further ado, let's get right into building it. Okay, so this is what our marketplace app will look like. So it will just contain a simple form where we can put in information about the listing. So let's just create one, item 1, give it a price, and hit add. And it will obviously prompt the sCrypt wallet, so we just hit commit. It takes a few seconds and the item should show up. So let's try to add another one. Different price, commit again. There you go, it also shows up. So each item will also contain the seller's address. So if we hit buy, for example, could be any wallet, the smart contract in the background will make sure that the seller gets paid. Alright, so let's start writing our application. So first of all, we're gonna create a React app, and the name is gonna be marketplace app. And obviously, because sCrypt is TypeScript based, we're gonna pass the template argument with the TypeScript value. Once it's done, we're just gonna switch directories into the project and initialize a Git repository. And also create a commit. And then we're gonna initialize sCrypt inside the project. So we're gonna run npx sCrypt CLI init. And once it finishes, we're gonna open it in VS Code. Here we go. Okay, so let's go straight into writing the smart contract code. So because the command created a bunch of boilerplate, we can just clear this up for now. We change this to arguments, clear all the parameters, need them for now. And let's just declare what public methods our smart contract will have. So I think we'll need 2 of them. So the first one will be to add an item, and the second one will be to buy an item. Okay, so let's declare what an item will actually be. So let's just declare a custom type. And the item is gonna have a name firstly, and a price, which is gonna be a big integer, and the seller's address, right, which is a public key hash. Okay, we're also gonna need a way to store these items now, so we're just gonna use an array. So let's define it as a stateful property. It's gonna be called items. It's gonna be fixed array of items, and let's also add the size. So I call it item slots. This is the maximum size, the number of slots that our smart contract will contain for items. Now obviously in a production example you wouldn't really do it this way, because you don't want like an upper bound of the number of items that are listed on your application. So instead you would probably do each trade within a separate smart contract, and you would deploy like an indexer service to keep track of them. But for demonstration purposes like this tutorial, it will suffice to keep track of them within the smart contract itself. So let's just make it a maximum of 10 slots for now. And also make the array this size. So item slots. And this needs to be true. And because the slot can also be empty, we're gonna add an additional flag to our item type, which is gonna be just a Boolean flag to indicate whether the slot is empty or not. Okay, so inside the constructor, let's just fill it with empty slots. So we're gonna do this.items, and we're gonna use the fill function of sCrypt. The name can just be an empty byte string. Price is gonna be 0, doesn't really matter, since all we care about really with an empty slot is the flag. Which can also be just 0 bytes. And the last thing is gonna be the flag. It's obviously gonna be false. Oops, sorry, it's actually should be true as it indicates an empty slot. And we're also adding the size. So item slots. And that's pretty much it for our constructor. So let's just continue on and implement the addItem method. So the addItem method is gonna take in as parameters firstly the item itself, which is gonna be of item type, and also the index of the slot, right? So item index. So this is where the contract is gonna put it within this array that we defined before. So the contract will first check that the slot is actually empty that we're trying to add a new item to. So we're going to assert that the item at this index will have the empty slot flag set. Now we do this number cast solely because in TypeScript array indices are just regular numbers, but sCrypt smart contracts work with big integers, so not to confuse the compiler, we just cast it to a number. Okay, so moving on, we also need to check that the newly added item won't have this empty slot flag set. So we're just gonna assert that item is empty slot is set to false. Additionally, we also check that the newly added item's price will be bigger than 0. Okay, so I think this is pretty much it as for the assertion on the new item. So once that passes, we can just simply add it to the array at the specified index. So we're gonna do item index. Oh, it's to be items. It's gonna be the new item. And obviously, lastly, because this is a stateful contract, we need to ensure that the next output will have the smart contracts instance with the updated array. So let's just write outputs, and we're gonna build the state output, and the value is just gonna be the same as before. So we're gonna do this.context and the UTXO value, so it doesn't change from the previous instance. And we're also gonna add change output if it's needed. Go. And obviously we're gonna check that the hash of these created outputs matches the one in the context. So context hash outputs. That's pretty much it for the add item method. So let's move on to implementing the method for buying an item. So this time we don't need to add a new item, so we can just pass in the index of the item that we're trying to buy. And let's retrieve the item from our array. Okay, and here we can already set the slot to be an empty one. So on the same index, gonna set the empty slot flag to true. So this way it can be reused in the future. And lastly, obviously, we're gonna propagate the contract instance like with the add item method, but this time instead of only adding the change output, we will also add an output that will pay the seller of the item. So instead of this, we're just gonna call a util dot, oops, need to import it, utils, okay, and we're gonna build public key hash output, which is just a regular payment. And the recipient is gonna be the item's seller, and the amount is gonna be the price of the item. Now each time someone will try to buy an item, the smart contracts code will ensure that he also pays the seller the appropriate amount. So that's pretty much it for our smart contract code. So we can try to actually compile it. So we just run npx sCrypt CLI compile. And here we go. It was actually successfully compiled. And now also let's try to deploy it. So instead of compile, we're just gonna say deploy. Run. Oops, so yeah, we forgot to actually adjust deployment script. So we're just gonna go back to VS Code and open this deploy.ts file. And it already indicates where the error lies. So because the constructor of our smart contract doesn't take any arguments, we can just leave that empty. And we're also gonna adjust the amount that's gonna be locked into the smart contract to 1 Satoshi because we don't need more. So let's go back and deploy again. Okay, now it also errors because we haven't funded our address yet. Now we could take an already funded private key from our Sensilet wallet like we did in the last video, I believe, but we can also just copy this automatically generated address and fund it using sCrypt's faucet. So let's just copy it and go over to the faucet. Go, paste it in, and click get BSV. And now let's just rerun the deployment command. Close this. And there you go. Our smart contract was successfully deployed. And here's the transaction ID. So now let's move on and let's implement the actual client application that's gonna be used to interact with this smart contract. Okay, let us go back to VS Code and open the index TypeScript file. And in here, we're just gonna import the artifact that was created during compilation of the smart contract. So just gonna import it from artifacts folder, and it's this JSON file. And then we're gonna load the artifact. So the app won't have to compile it again. You can just go from the artifact And since we're here, we can also initialize the sCrypt service provider. So we're just gonna do sCrypt, import it, and call the init function. And in here, we're gonna define an object, the API key, and we're gonna load the API key from an environment variable. So we're gonna do process.env, and it's gonna be called React app API key. So this way we can just simply put the API key inside the .env file. And here we're also gonna pass in the network, which is gonna be the testnet network. Oops. Let's just import this networks testnets. Here we go. So now let's just simply go fetch the API key. Let me just open a new browser window. Go to sCrypt.io. And sign in. And then just hit copy of the testnet key. Go to the .env file. Paste it in here. And let's name it React app API key. Just like that. And save it. Okay, so now we can start defining the application's layout. So if we open app.tsx, we already have some code in here, which the majority of which we don't need, so we can delete this header. And let's just add two new items. So the first one is gonna be the form to add a new item, which we're gonna call new item, and we'll have a callback method which we're gonna call onAdd, and define the callback function here. We're gonna do const handle add. It's gonna be an asynchronous function, and we're gonna write the body later on. So for now, just add another element, which is gonna be the item list. We'll also have a callback for a buy event. We're gonna call it handle buy, and this callback is gonna be executed each time someone clicks a buy button. Buy. And this is also gonna take in a list of items, which for now we can just leave empty. Also, actually, let's move this function inside the app function itself. Okay, now let's create a new file where we will define how the form for the new item will look like. So let's call it new item.tsx. Open it, and let's just copy this from here, and we can adjust it. So let's delete this, and let's call it new item, and as a parameter it will take the onAdd function. Let's delete this, and also the layout. Okay, and here we're gonna use some components of the MUI material package. So let's install that. So let's go here and do npm install MUI material. And yeah, there's also these other packages which we may have to use later on. So let's just hit enter. Once done, we can go back here and just change this to a box element. And it's gonna be a form. So we can write component equals form. Inside of this, there's gonna be first text field for the name. So it's gonna be ID name, label, let's make this name a variable. For this we're gonna use the useState function, and by default it's gonna be an empty string. Also set the onChange function, just gonna take in the event, and it's gonna set the name variable's value. We'll make it full width, and it's a required field. So we just hit the required flag. Okay, so that's for the first text field, and the second one is gonna be one for the price. So rename this price. Okay. And lastly, we'll need the submit button. So type submit. Go. And also import these elements from the MUI library. Here we also have to set the onSubmit function. Go handle submit, and let's define it here. And submit. This is gonna take in an event. So we're just gonna prevent the default behavior that, and instead we're gonna call the onAdd function, pass in an object with firstly the name and secondly the price, which will also convert to a number. Price. And I think I made a typo here. So components. Okay. Like something's still wrong. Okay. Implicitly has any type. Yeah, I think this is due to the TypeScript compiler being in strict mode. So we can just delete this line in the tsconfig and save, and now it should disappear. Yep. Okay, so make this new item and save. So I think that's it for the new item form. So let's move on, go back to app.tsx and import this firstly, and now let's move on to defining the item list. So again, we'll make a new file. This time we can just copy the new item file paste, rename it to item list.tsx, dApp, rename it list, and in here I have the onBuy function and also the items. And let's just delete this stuff here. And in here I have a box. This time it won't be form. And inside of this box we'll try to display the items. So we'll do items map, and in here is gonna be a function. So the parameters are item and its index. And if the item is not an empty slot, then we'll display it. Otherwise, we'll just ignore it. Do this and we'll display it as a cart element. This is gonna have cart content. And in here, we're gonna display the name firstly. So we're gonna use the typography element. Okay. And we also need to convert the item's name because it's a byte string, so we need to convert it to UTF-8 string. So we do buffer from item.name, and it's hex formatted, and we'll convert it to a string, which is an UTF-8 string. Okay. And then we also do the same for price and the seller's address. So the price, we do like this, SV, and because initially the price is in Satoshis, we can just divide it by 100 million, and then it will be denominated in BSV, which is 100 million Satoshis. So Leslie the seller, and it's just gonna be seller address. Okay. Of course, lastly, because each item will also have a buy button, we need to define that. And we're gonna set on click handler, which is gonna be just a function that will call the onBuy function, and it's gonna pass in the index of the element. Okay, we're gonna put in text buy. Okay, let's save this and go back to app.tsx. And let's just import this new item list. Okay, so I think we're ready to try to run this thing to see what we have so far and if it works. So let's go back to the console and just simply do npm run start. And we can see we already got the form, but obviously it doesn't do anything yet because we haven't implemented the callback functions. So we're gonna do that next. So let's go back to VS Code, and actually first let's just implement the useEffect callback, which is gonna be called upon initialization of our application. So once you open it, let's do a function The second parameter is gonna be an empty array. And let's write this function. So in here, we're gonna initialize the signer, which is gonna be a sCrypt signer, since that's what that's the wallet that we use. And we also need to create the provider, which is gonna be the sCrypt provider. Okay, now let's store this signer as a reference for a React app. So let's define the reference. Use ref. It's gonna be of type sCrypt signer, and let's store it here. Current signer. And after this, we're gonna fetch the contract instance that we deployed earlier. So let's define a separate function for that. I'm gonna call it fetch contract. Okay, so on error, we're gonna just log it. In here, I'll call await sCrypt contract API and get the latest instance. And as the parameter, it's gonna be the class of our smart contract and the contract ID, which is gonna contain the transaction ID of our deployed contract and also the output index, which is in our case 0. So let's just go back to the console and try to find our transaction ID, which seems to have disappeared. So no worries, let's just deploy another instance. Here we go. So let's just copy the transaction ID and paste it inside the string. Alright, so that's it for the retrieval. Now we also need to again store it in a variable. So let's call it contract instance and set contract function. We're gonna use state function, and the type is gonna be our contract class. Here, let's just do set contract and the instance. Oh, and this needs to be a number, not an integer, not a big integer. Okay, so the last thing we're gonna do in this initialization function is we're gonna create a subscription for our deployed contract instance. So we're gonna do subscription variable. I'm gonna do sCrypt contract API dot subscribe. Go. And in here, the first object is gonna again contain our contract class. Oops. Let me just copy this from here actually. Or maybe even make it global. So let's do contract ID. It's gonna be this. that and just contract ID. And also down here, E. The second parameter is gonna be the function that will be called upon our smart contract update. So the parameter is gonna be contract called event. Marketplace app, and inside the function we're gonna simply update the contract instance. I'm gonna do e next and the first next instance, and let's just give these values keys. It's gonna be class and ID. Okay. Also, on the end, when the app closes, let's just unsubscribe from our subscription. So we're gonna do subscription, subscribe. So I think that's it for our useEffect function. So we can move on to implementing the function that's going to be called when a new item is being added to the marketplace. So this is going to take in a parameter new item, which is going to contain the item name and also the price, which is a number. Because it comes from our front end, we'll convert it to a big integer later on. Okay, so in here, let's get a signer. Okay, so sensitive signer. And we're gonna do a check if the contract instance already was set and the signer successfully connected. Or rather was initialized, then we can proceed. So first we're gonna authenticate the sCrypt wallet. So we're gonna do signer request authentication, and if it's not, it fails to authenticate, then we're just gonna draw an error. Okay. So next we're gonna connect the signer to our contract instance. Next, because this is a stateful contract, we can proceed with creating the next instance of the contract, which is obviously gonna contain an updated list of items where it will contain the new item that we're just adding. So we can do next instance equals contract instance dot next. And now we can construct the new item object. So yeah, let's just first get the address, and we're gonna get the address from our signer. So yeah, let's do signer get default public key and turn it to hexadecimal string and hash it. That will give us an address. Let us also get the item name which we're gonna need to turn into a byte string, because it's by default it's UTF-8, but sCrypt supports only byte strings. So we're gonna call the toByte string function, and we're gonna do item.name. Oh, sorry, it's new item.name, and the second parameter is gonna be equal to true, because it indicates that the string is UTF-8 formatted. Okay, next thing is gonna be the price, which is gonna be a big integer. So we need to convert it from a number to a big integer, and also it's denominated in BSV, and we're gonna convert it into Satoshis. So we're gonna do new item price, and we're gonna multiply it by 100 million. 100 times 10 to the power of 6. Right, so let's combine this into an item object. So we're gonna call it toAdd. It's gonna be of type item, obviously. And I'm gonna do name, and the next thing is price, the seller address, and the last thing is the flag that indicates if it's an empty slot or not, and obviously in this case it isn't. So we're gonna do is empty slot is false. Okay, moving on, we're gonna have to insert this item object into the array of our smart contract instance. So because it might already contain some items, we're gonna find the first empty slot that we can insert into. So let's just do a for loop. We're gonna do loop over the array. Okay, let's retrieve the item. It's gonna be contract instance items and the index I. And if this item is an empty slot, then we can actually insert it. So let's do the next instance items. We're gonna insert it at this empty slot. It's gonna be toAdd. Okay. And let's just store the index for later on, because we're gonna use it as a method parameter. So we're gonna call it item index. Just make it undefined at first, and in here we're gonna set it to I, and we can break here. Okay, and obviously if this item index stays undefined, then that means there's no empty slot left. So we're just gonna do a quick check here. If item index is undefined, let's just let's just log the error. No empty slots left, and we're just gonna finish the function, so it doesn't do anything further. And now that we got all the data that we need, we can actually call the deployed instances public method. So we're gonna do contract instance dot methods, and it will be the add item method, and it's gonna take as arguments the new item and also the index in the list of the new item. And lastly, the method call parameters. We're just gonna do next, and here we need to pass the next instance that we just created. So we're gonna do instance, it's gonna be the next instance, and also the balance of the new instance, which is gonna be the same as before. We won't change the balance. Okay, so once this finishes, we can just do then, because it's an asynchronous event. So yeah, and here we're gonna have the result of the function call, the method call rather. And let's just log it to the console so we know what's going on. And add item call transaction so we know which transaction it is latest. So results, and it's going to be the transaction ID. And also in case of an error, let's just do catch, and this is going to be the error object, add item call error, and be all right. Okay, so that should be it for the add item function, and let's just try to add one. So in here first we need some way to display the items, because currently it just takes in an empty array. So instead we're gonna do contract instance. If it exists, then we can just display the contract instance items as an item array, and else it's gonna be just an empty array. So let's just try to add an item and see what happens. So in here, I'm gonna start the application again. Okay, back to the browser, refresh, and let's just call it test1, give it some price. So open the console. Okay, seems like the connection to the smart contract instance was also successful. So let's just hit add new item. It seems like it's not doing anything, so I think something's wrong with the button. So let's just check it, maybe see if this actually runs. So do test, refresh. Okay. Okay, this actually runs. Check the next function as well. Let's delete this. Go to app. Spawn that. Okay, this runs as well. So maybe we haven't set the instance or the signer, so let's just check that quick. And also log the item. Okay. So it seems like the contract instance isn't defined. So let's just check. Oh yeah, forgot to call the fetch contract function here. So fetch contract. Yeah, okay. I think that should fix it. So let's go back and try again. Load. Okay. It says unlock wallet first. Let's try to do that. Yeah, it's locked. Okay. Let's try again. Okay, now the wallet actually prompts us to update the smart contract. Let's just hit commit. See what we get. Okay, it actually successfully did update the contract in the background, but for some reason it's still not displayed. So let's figure that out. So let's go back to VS Code. And I think the first thing we should check is whether the subscription actually works. So let's just log this here. If we actually get something, yeah, maybe right from script service description. Okay. Down. I think this should be fine. As maybe can we log here? Item. Yeah, let's just try that. See what we get. Okay, so yeah, I think we actually have the item data. Not sure why it doesn't display anything. So let's just maybe try log it here. Oops. Yeah, this. Maybe try changing these parentheses. Oh, okay. Now it actually showed up. Let's just refresh. Right. It also gives us a warning that each child must have a key property. So maybe let's add that. So I think this refers to card. So let's just make it key. And it's gonna be just the index. Try if it goes away. Okay, cool. Now just to test, let's maybe try add another item. Oops. Should prompt us. Hit commit. Cool. Now they actually display. So now let's implement the callback for the by click. So in this case, we should call the other public method of the smart contract. And yeah, let's just go ahead and write the function. So go back to app.tsx, go down to handle by. Here, just the same as we did in the handle add function, we're just gonna connect to the censored wallet and do an authentication. Close this. Okay, then again, we're just gonna make the next instance of the smart contract. So let's just do contract instance next. Now in this next instance, all we have to do basically is just mark the slot that we have bought as an empty slot. So yeah, this will also take an index. It's going to be a number. And what we'll have to do is here to the next instance, items to index, and just set this to true. That's it for the next instance. And now we can do the contract method call. So the methods, and this one's going to be called by item, and what it takes as a parameter is just the index of the item that we're buying. Also here, well, never mind for now. Let me actually just copy this from here, and we're just gonna print item call section. Yeah, it's gonna be a by item call and by item call error. Okay, so one thing remaining, you might recall from writing our smart contract that the by item method will also make sure that there's an additional output where the seller address gets paid the appropriate price, right? So for that, because doing like this additional output isn't standard, we have to override the construction method of the should I say transaction construction. So that's called the transaction builder, and we're gonna write a custom one where we will add an additional output that will pay the seller. So to make things a bit faster, let's just go into the browser and let's go to the sCrypt documentation. Just write docs.script.io, and under the how to deploy and call a contract section, we just go to the how to customize a contract transaction page, and in here we'll have an example of this transaction builder for a method call. So let's just copy this, go to our contract file and just paste it in here and import. Yeah, this is for the auction contract, so let us change this to our contract, which is the marketplace app. So check if there's anything else. Yeah, and imports, missing imports. It's just gonna be BSV prefix. That. This. Okay. Let's also add, let's make this the build seller payment output, and it's gonna be, let's just get the reference to the item that we're just adding. It's gonna be current dot items, and yeah, in here instead of bidder, I'm gonna take the index, the slot, and convert it back to a number, and this is gonna be the new item that we're adding. In here, gonna do just item.seller address. Also in here, we're gonna need a reference to the next instance. So let's just delete this bit, it's a leftover from the documentation. And yeah, for the next instance, we're gonna pass it via the method call options. Let's go back to app.tsx and just like we did with the add item, put this in here. So next instance and its balance, and now we can here we can do options dot next dot instance. Let me just define it outside here. Next options next, and we're gonna do this as stateful next marketplace app, and in here you can just do next instance, and this is gonna be next balance. Okay, so yeah, and here again it's gonna be next instance and next balance. Lastly, of course, we need to bind this transaction builder inside of here. So we can do just here contract instance, and we're gonna call bind tx builder, and we're gonna specify for which method we're gonna bind it to, and it's gonna be obviously bind by item. And let's reference the actual builder function. So it's gonna be let's rename this to by tx builder. Okay, should be also renamed here now. By. Okay, cool. So I think we can go ahead and try to run this. So let's go back to the browser. Let's just refresh quickly. And yeah, maybe try to buy this first item. Hit buy. Okay, it says invalid argument, address is required. And it's in app.tsx and line 140. So let's go back. Let's go to line 140 here. Oh, this just seems to be the error. Just to change this. Oh yeah, I think I know what the problem is. So didn't specify, because we have a custom transaction builder, we also have to specify the change address here. So let's just do this. Well, let's do, oops, let's do it after next. Change address, and we're just gonna use the signer's default address. Get default address. Yeah, this is our basically the address of our sCrypt account. Yeah. And it's on, yeah, it's an asynchronous function, and just await it as well. Save. Let's go back to the browser and refresh and try again. Okay, hit buy. Okay, so it created the prompt, so that's good. And we can see the second address, it also pays the seller. But obviously here we're the seller, we use only a single sCrypt account for now, so yeah, we're just gonna pay back ourselves basically. So let's just try. Okay, so seems like an error was thrown. And it seems like the execution of the contract code failed, so let us explore why this might happen. So this first thing, go back to the contract and let's check the buy item. So yeah, we update this empty slot flag to true, should be good, and we just construct the outputs. It's a public key hash output, so yeah, we use the write hash function. So maybe let's just print this next instance here, and maybe the items bit. See if it actually was updated. Go to the browser, refresh. Oops. Oh yeah. Buy. Cancel this and see. Okay, we got 2 items and the first flag should be set to true. That's okay. And the second one should remain false, and that's also okay. So that's okay. Let's go back, check further. Maybe delete this line. Okay, yeah, we have the contract input, that should be fine. And also the next instance output should be next locking script, and the next balance is also fine. And then we have the seller payment output, just oh, I think I see. So yeah, we didn't set the right amount of the seller's payment output yet. So this needs to be the item's price, obviously. So let's just change this. You just do number, item, and it's gonna be the item price. So for anything else, it's only the change output, and yeah, I think everything else should be fine. So let's try again. So we saved it, refresh, buy again, hit commit, bang, it disappeared. So that's good. Yeah, I think logic wise we're pretty much done now. I think maybe we should also make it a bit prettier because it looks sort of weird. So let's go back to, let's go first to the new item form, and maybe add a margin to the box itself. So we're gonna do SX, it's gonna be M, and let's just set it to 2. And maybe here we're gonna set the margin, let's do normal, and here as well. Also let's add a margin to the button, and let's make it on top. Okay, let's just take a look at how this looks now. Yeah, it looks a bit better. So style this button, do variant, and do contains. Okay, let's go to the item list, and yeah, maybe style this box. Let's do SX. I'm gonna do display. It's gonna be flex. So flex wrap. And also we're gonna do a justify content to the center. See how that looks now. Yeah, it looks a bit better. So maybe let's try adding another item. Yeah, maybe also add a margin. Yeah, okay, display side by side now as well. It's good. So maybe here, let's just do sx again. Do margin to 2. Okay, I think it looks good enough for now. Maybe one thing, this seems to be, the address seems to be displayed in raw hex format, so maybe display it in a wallet format as standardly Bitcoin addresses are. So back here, let's instead of this do PSV, port it from sCrypt yes, and do address from hex and just pass this in. And now display it, I think as a string should do the trick. So let's just try that. Okay, my buffer must be exactly 21 bytes. Yeah. I think we can fix this by just adding the 6f prefix to the address, and that just means that it's a testnet formatted address. I think that should fix it. Yeah, okay, now it correctly displays the addresses like our wallet does. So cool. I think we're pretty much done with the application now. So again, just quickly to check, to remind you that everything that our application does also gets updated on chain in a smart contract. Okay. So the smart contract keeps track of the items and the prices and all the rest of the information, and it also ensures that upon calling the buy method, for example, that the seller actually gets paid. He cannot unlock it without paying the seller. So this is all the smart contracts job. There is no backend server or anything like this for now. So let's maybe try to list another item from another account. So this is Alice. Let's switch to Bob, for example. So Bob will have obviously a different address. So maybe try to list Bob's item. Okay, give it a price. Add. Prompt us again. Okay, hit commit. There you go. The Bob's item is also listed, and every other client should now, because it's subscribed to contract events, it should also receive this item and display it. And now, for example, Alice sees this, that Bob listed an item, and she can just hit buy, commit, and Bob will get actually paid, right? Oh yeah, well, we didn't switch the account, so now unfortunately Bob bought his own item again, so but anyway, you get the idea. Now again, because you might have noticed already, the slots, because of the way smart contracts work, they need to be of finite size, so they can't be extended like indefinitely. Well, they could be using byte strings, but that would also add a lot of complexity, especially since we were in a production marketplace or something. We would have thousands of items listed, and consequently the size of the smart contract would grow indefinitely. So in a maybe in a production grade example, each trade would be a separate smart contract, and you would have some sort of indexer service running in the background, which would keep track of these contracts, and that way you wouldn't have this overhead of the smart contract size. But for our demo application, or even for like a smaller marketplace, or maybe like a web shop of, you know, some shop would list what they have for sale, something like this that we just wrote would just work just fine, basically. So the full code will be on GitHub, and it will be linked in the description of the video. And yeah, in case any of the concepts that we used during the implementation of this application didn't make sense to you, I highly recommend going over the documentation of sCrypt. It will make things a lot clearer to you. And yeah, let me know if you have any feedback on the video or what to improve. And of course, stay tuned for the next video.